Okay, let's talk about transformations of the exponential function. So this right here, this is considered the parent exponential function. Notice it curves up, it shoots off towards positive infinity, both for the x and the y axis. Also, it looks like it's actually touching the x axis, but it's not. What is happening is this graph is getting closer and closer and closer to y equals 0, but it never reaches that value. So this graph has a vertical, or I'm sorry, not a vertical asymptote, a horizontal asymptote. And the horizontal asymptote for the parent function is this. Notice what happens if I move this graph. Notice the horizontal asymptote goes with the graph. Watch what happens when I do horizontal movement and move the graph left and right. Stretches and the arc that moves up towards positive infinity is moving left and right. And notice that the the horizontal asymptote is not moving. So we do have an A value. Right now, the A value is just a 1, which means there's no stretch or no shrink. And I'm talking about a vertical stretch or vertical compression. When the A value is greater than 1, notice that the arc shoots up pretty significantly. So it's a vertical stretch. If the A value is a fraction, notice the curve flattens out a little bit. Of course, the A value can be negative. And when the A value becomes negative, notice that graph is shooting down towards negative and positive infinity along the x and y axis. So let's talk a little bit more about identifying these transformations. Let's recap what we talked about. First of all, you got a horizontal asymptote, y equals k. And remember, that is a dashed line on. Okay, and then next we want to talk about is domain. The good thing about domain for these functions, since it goes in both directions, y'all, it's always negative to positive infinity. So that's good. That's going to be an easy one to remember. For the range, it really is dependent upon k. So the range, if the graph shoots up forever, it is going to be whatever k is to positive infinity. And that's when the a value is greater than 0. In other words, a is a positive number. If a is less than 0, a negative number, then your range is going to have a ceiling at k. So it's going to be negative infinity all the way up to whatever that k value is. One more thing. We need to review growth and decay. This is an Algebra 1 concept. So remember, if your base is greater than 1, it's going to be a growth. If your base is less than 1, but at the same time positive, so a positive number, so greater than 0, that's going to be a decay. So remember, any fractions, anything less than 1 positive, it's going to be a decay. Okay, so let's go ahead and take a look at this graph. First of all, I don't have an A value. Well, I really have an A value. The A value is just 1, which means there's not a vertical stretch or a shrink. I do have a horizontal translation. That's going to be 1 unit to the left. And this graph has been shifted down 6 units. So let's go ahead and take a look at what's going on here. First of all, let's determine if it's a growth or a decay. Certainly a growth because the b value is greater than 1. So this is a growth exponential function. We also know that it is 1 place to the left. Wow, I can't spell left and I'm recording. That's embarrassing. Remember that whatever is with the x, whatever the h value is, remember that's opposite. That's going to hold true just like it has for every other function. And then this is going to be 6 units down because our k value is a negative 6. All right, so let's talk about domain. Remember, domain's a piece of cake, negative to positive infinity. And then our range is really going to be based on our k value, and it depends if the graph goes up or down. The graph goes up, so the range starts at the k value, which is a negative 6 here, and then it goes on to infinity. And please remember that is a parenthesis. We don't include the negative 6 because remember, that's the asymptote. In fact, I'm going to label the asymptote so I just don't forget. One more thing I want to talk about is the y-intercept. So remember, when you need to find the y-intercept, your x is 0. So we're just going to do some math here. So I'm going to plug in 0 for the x value. So y is going to equal 2, 0 plus 1, and then minus a 6. So this exponent becomes just to the first power, minus 6. So y equals 2 to the first power is just 2. 2 minus 6 is going to be a negative 4. So our y-intercept is right here at the 0, negative 4. So on the graph for this example I showed you, but just remember sometimes you will have to calculate the y-intercept. Let's go ahead and take a look at the next one. So number 2, first of all, this is going to be a decay. I know it's a decay because the base, of course, is a fraction. And there is not any number out front, so there's not going to be a vertical stretch or a vertical shrink. But we certainly have some horizontal and some vertical transformations. It is going to be 1 unit to the left, 6 units down. So 1 unit left and 6 units down. Okay, let's go ahead and talk about domain and range. Domain, piece of cake. Range, the graph opens up on the left side, which means it's getting closer and closer and closer to the asymptote over here on the right side. But remember, if the A value is 1, which it is, it's understood to be a positive 1, this K value is still as low as the graph is going to get. So the K value is negative 6. And remember, if I scanned with my pencil, the arrow points up on the positive y value. So that is a positive infinity for the range. All right, y-intercept. So I'm going to have a 0 here, and I'm going to plug it in and do some math on that. So for the y-intercept, it is going to be y equals 1/2, and that's going to be a 0 plus 1 minus a 6. Y is going to equal 1/2 raised to the first power minus 6, which of course is just a half. So a half minus 6, our y-intercept is going to be at 0, 5.5. Okay, let's take a look at some equations and figure out what those transformations are. So for number 3, again, I do not have a number out front here. If I do not have a number out front here, then there's not going to be a stretch or a shrink. So what's going on here is it's a growth. And I know it's a growth because the base is greater than 1. It is going to be 1 unit to the right this time. And this graph has been shifted up 8 units. If we look at this one right here, this one, oh, hold on, let me back up. Domain and range. Domain, always the same thing. Range is going to be 8 to infinity. Y-intercept. We're going to plug in a 0 and we're going to solve. When I plug in a 0, if you notice up here, this is going to be 2 to the negative 1 plus 8. And remember, negative exponents are on the wrong side of the fraction bar. So what this actually means is 1/2 plus 8. So your y-intercept for this is going to be 8.5, and I'll just write it as a decimal. All right, let's take a look at number 2, or number 4. On number 4, I know it's a growth because that's bigger than 1. It's going to be 1 place to the left and then 4 up, 1 unit left, and 4 down, not up. It's down because that's a negative sign. Domain, negative to positive infinity. Range is going to be a negative 4 to positive infinity. And then let's go ahead and work on that y-intercept. So for the y-intercept, we're going to plug in 0 right there. So 0 plus 1 which is going to be a 6.